So, hi, my name is Alex. I'm a software engineer on the Xamarin/Mono team at Microsoft. I joined Xamarin roughly 4.5 years ago. That was actually 1 year before Xamarin got acquired by Microsoft. So I kind of got into Microsoft that way. You can find me on like my email or GitHub or Twitter. So if you have any questions, feel free to shoot me an email or send me a Twitter message. Today I'm going to be talking about .NET 5. So just a quick show of hands, how many of you know or have heard about .NET 5? Okay, that's great. So yeah, so I'm kind of focusing on what .NET 5 means for the mobile workload, because obviously I'm Xamarin, so we care about the mobile stuff. Does everybody know what Xamarin is? Just another. Okay, so I guess we can just go quickly over this slide, but I'll just mention it anyway. So Xamarin is basically, what we do is we provide a .NET framework for mobile workloads. So for iOS, Android, and also some game consoles like the Xbox or PlayStation. And like what we do is we map the native APIs of the platform. So for example, on Android, you have, I don't know, 100,000 APIs from the Android API, and we map them one-to-one to .NET. So you can use your normal C# or F# and program your app against the Android framework or the iOS framework, and use basically only C# and whatever tools you're familiar with, like Visual Studio or like the C# compiler. And Xamarin in turn is based on the Mono framework, or the Mono runtime. And for those of you that don't know, Mono was created like in 2002, I think, so a long time ago, shortly after the .NET framework was released. And the main goal back then, and still is to provide an open source like targeted at a mobile like environment version of the .NET like specification that runs on mobile platforms mainly. And as I said, Microsoft acquired Xamarin in 2016, so that's basically when we got into Microsoft. And also, most of you might not remember, or hopefully don't remember, but Xamarin wasn't open, like the proprietary pieces of Xamarin wasn't open source back then, and Microsoft actually open sourced them. So Mono always was open source, but at Xamarin we built proprietary stuff on top of it, and when we were acquired, Microsoft open sourced all of that. So that's really nice. Yeah, so a little short piece of history. As I said, .NET Framework got released, and Mono, and then we have like, this is a very simplified picture, but then we have like 2 decades, and now we are at this kind of mess. So we have a lot of different .NET implementations. We have .NET Core, we have .NET Framework, with Mono, we have .NET Native, which is used for UWP, and I'm leaving out a lot of other stuff like Silverlight and .NET Client profiles and all that stuff. And as you can see, it's not really ideal. Every platform and every runtime has different characteristics and different strengths and different drawbacks, and it's kind of confusing. So we realized this was a problem, and so this 2014, so this was before like Xamarin or Mono was part of Microsoft. And we realized this is a problem because people wanted to basically build libraries that ran on .NET Framework and Xamarin and .NET Core. It was kind of difficult because there was not one shared library target that you could use. So what we introduced back then was .NET Standard. And .NET Standard was a set of API specifications that every .NET platform had to meet in order to be compatible or to meet the .NET Standard spec. And that's what we did in Xamarin, that's what .NET Core did, and also .NET Framework. So with .NET Standard, you could write one single library that ran on all these platforms, which is great. But if you look here, you still have different implementations of the runtime for .NET Framework, for .NET Core, for Xamarin, and on top of that, you also have different implementations of the base class libraries, which is like the .NET framework, what you think about like the system namespace. It's different between .NET Framework, .NET Core, and in turn Xamarin and Mono. So we are kind of developing 3 times the same thing, even though we're one company now. So this is, again, not ideal. And so what we are doing now to rectify that is we are actually basically taking the best pieces of each of these technologies and merging them into one. And we're calling it .NET 5. So it's kind of an evolution of what .NET Core was, and we're basically taking some pieces of Mono and bringing it into .NET Core, and the end result is what we're calling .NET 5. So we will have basically a shared, we will have a runtime that exposes the same capabilities, whether that's like the traditional .NET Core runtime, which is CoreCLR, or Mono, and we will share the same base class libraries. So what you might know as CoreFX. So CoreFX is the managed implementation of the framework that .NET Core uses, and we are going to use it now as well for Xamarin. And on top of that, we are making the .NET release schedule way more predictable than in the past. In the past, you basically could guess when the new .NET would be released, because there might be either some Windows release or some developer conference or something like that. And that's like not great for customers that want some predictable schedule. So what we will be doing is each year we will release a new major version of .NET. So in November 2020 we will release .NET 5. 1 year later it will be .NET 6. 1 year later it will be .NET 7, and so on. And each second release will be an LTS release. So LTS is long-term support, which means it will get like support fixes or security fixes for a long time. So if you need, for some reason, you need to stick with one stable target, you can pick the LTS releases. And if you want the latest and greatest stuff, you just pick the yearly release, which has all the latest stuff. Yeah. And we can do minor releases if we need to for some reason. But I mean, usually, if you want to use the latest stuff, you can just like download the preview builds that we publish on GitHub, or even build it yourself, because as you know, .NET Core is open source, so you can just go to GitHub and clone the source and build it yourself and do whatever you want with it. Yeah, so this is just an outline of the most important stuff. I mean, .NET 5 is a huge topic, but the main topic is it supports all the .NET application types, which means with .NET 5 you can target web, you can target client, you can target the server, you can target the cloud, you can target mobile devices, you can target games with Unity. All basically under one single umbrella, which is consistent across all the stuff that is in it. Everything will be using one BCL implementation, so which is great because we don't need to spend time and develop the same thing 3 times. And everything will be using the same toolchain. So everything will be using SDK-style projects, which is the new project format that was introduced with .NET Core, which is like way more easy to edit by hand, or like you don't need a huge GUI for editing the project files. And it will be driven by the .NET CLI. So you have a .NET command line. Of course, you also have IDE support on top of it. But if you're like a command line guy, then you can just use the .NET CLI and do everything that way. .NET 5 will support just-in-time compilation, so the traditional JIT that we know and love for many years. And something that we'll gain from Mono is the interpreter. So now you can basically run in contexts where you cannot do JIT, which is something that I'll explain later on. And also static compilation, which kind of was possible with .NET before with NGen, but with Mono we have a very good backend for that, which is LLVM, and it's got a lot of nice optimizations for static compilation. And one other thing that will be coming to .NET 5 is a single binary deployment. So no longer do you need to have like 30 or 50 different DLLs in a folder and zip that up and ship it somewhere. With .NET 5 you can have a single binary that bundles all that together, and then you just copy it or deploy it however you want. And once you run it, it will extract and run whatever it needs. So just a quick summary of, you probably seen this before, but it kind of really nicely shows like that .NET, you can basically do anything you can imagine. As I said, you can do desktop with WPF, you can do web with ASP.NET, cloud, mobile with Xamarin, and you have great tool chains for that as well. Visual Studio, Visual Studio for Mac, Visual Studio Code, and of course the command line interface. Yeah. Any questions so far?
Yes.
Yes?
So will it ship also with Windows by default?
As far as I know, no. So Windows will only ship the traditional .NET framework that's been there since forever, and it will also not change. So Windows will still ship with .NET 4.8 or whatever minor version comes after that, but you get .NET 5 the way you get .NET Core.
Okay, but if Windows components will use .NET, the new web?
That is a great question for Carol. I do not know the answer to that, but yeah. Do you know if, like, for example, if some Windows component will wants to use .NET 5? Okay.
I can tell you horror stories about using .NET in Windows components that didn't go well.
Yeah. I mean, one of the obvious benefits for doing all that is that we are no longer tied to Windows. So we can ship independently of Windows. We can try to do things that wouldn't be possible in .NET Framework because it will break whatever text software is using .NET Framework, and yeah, so.
And the semi-binary will include the framework?
Yes, it will include everything
like
that
it does now with Core? And so you can use different versions in different apps?
Exactly, yeah. So right now with Core, what you can do is you can do the self-contained deployment, which is basically, it copies all the DLLs and the runtime and your app into a folder. And this is kind of the next step. So we basically merge all these and bundle all these files into just one binary. And at runtime, it will just extract to some temporary folder.
Those binaries will look a lot bigger than they were before. At least on Windows, on mobile,
yes.
It's the same, but...
Yes, but there will be tools to basically trim down the size. So one thing that we are bringing from Xamarin side is a tool called the linker. We call it the managed linker. It's, if you're familiar with the term tree shaking, it's basically trying to figure out which parts of the app or the framework even are not used. Because as you can imagine, like the .NET framework is like really huge, and your app probably only uses like 5 or 10% of it. So what the linker does is it goes through all the methods and all the things in your app, and just figures out what parts are not used, and then it just removes them.
Is it the same linker that Unity uses?
Unity
uses one?
I think, yeah, they're using the same. We're all using the same linker source.
Does it have the IL to CPP?
That's a different thing. So this is just
the IL.
Yeah. So what they're doing is they're taking the IL and basically transpiling it to C++, which is really cool. But before that even happens, they run the mono linker, and because there's no point in transpiling code that you are not even using. So that's basically the single tool that's being used across Unity, Microsoft, and Xamarin to just remove stuff that you don't need. Yeah.
I've got a customer relations question. How do you explain to a customer or to your customers that .NET 5 is a completely different product and not simply the latest version of the platform they have been using and paying for your products for the past decade and a half? So, and that .NET 4.5 is not simply a legacy train, and they basically can throw away their entire investment they have made into your product just because it stays on .NET 4.8.
Yes.
It's a marketing relations problem.
That is true. So, and since I'm an engineer, I'm probably not really qualified to answer that question, but what I can say is that the .NET framework that is in Windows today will be in Windows for like the next 10 years or whatever. So if you have software that is working today using .NET framework, it will be working the same way, like even in 10 or 15 years. So it's basically a decision on, do you want to move forward and use the latest stuff that will be coming out with .NET 5 and 6 and 7 and 8, or do you just want to keep your software working as is? So that's kind of the trade-off that everyone needs to do on
Yes,
their
but sometimes it's a complete rewrite of the application.
Yeah, sure.
Okay, I'm gonna inject, sorry.
Yeah.
So the official answer is that it's perfectly fine to stay on .NET Framework 4.8. It is the last .NET Framework shipped. If you have content there that works, keep it there. If you want innovation, but don't expect an innovation, expect security fixes, reliability fixes. That's it, it's done.
Yes.
Because you saw my talk about breaking changes. We cannot change anything. We fix perf, we improve perf, we break people. People hate that. .NET 5 is for people who have active development and want to move forward. So how to explain it to your customers, it's their choice. Like if you have low investment into product, keep it where it is. It's not, 4.8 is not going anywhere. As Alex said, it's part of the operating system. If you want innovation, if you want cool stuff, if you want perf, if you want new APIs, go to .NET 5, which is basically .NET Core.
Yes, but the problem is if you have a large product and you want to sell it to a new customer, the new customer will say .NET 4.8 is a legacy system. Why should we choose a product that is using a legacy system? But this is a product that has 10 years of investment in there.
Yep, and that's how you can tell them. This is 10 years of investment, and it's there, and it's as good as it's gonna get. Let's take it maybe offline. I don't think that. Did you want to do this kind of Q&A during your talk?
Yeah, sure.
I just don't want to steal your thunder. So let's take it offline. I'm more than happy actually to talk about it for hours. But
Yeah.
hopefully we will not need that much.
Yeah, and I mean, like it sounds like a lot of stuff is changing there, but hopefully moving your stuff from .NET Framework to .NET Core is not like a huge multi-year project. So yeah, of course it needs to be looked at in a case-by-case basis, but we try to keep a lot of stuff in there and compatible with .NET Framework. And that's actually one thing that we learned the hard way with .NET Core 1. We removed a lot of APIs and found out, yeah, it's kind of hard to move your project from .NET Framework. So with .NET Core 2, a lot of that got restored. So yeah, hopefully that will help you. Yep.
You say that .NET 5 will still adhere to the .NET standard?
Yes.
But will it be needed then?
That is a good question. That is something we are actively looking at right now, because if there's just one implementation, then why do you need .NET Standard anymore? But like we are keeping it, right now we are keeping it as basically the vehicle that we are using for designing new APIs, so that we can agree on something. But yeah, it's a good question. We're looking at that as well. Okay. So, as I said, .NET 5 will bring the best stuff of .NET Core and Mono into one product. And the way it happens is that .NET 5 will ship with 2 VMs. And VMs in this case is like the .NET virtual machine, not like a computer VM. So .NET 5 will have the Core CLR, which is what .NET Core is using, and it will have the Mono VM, which is what Xamarin has been using. And each VM, each runtime, has different strengths, has different drawbacks. Core CLR, for example, has been for many decades been tuned to be very high throughput, very efficient, very responsive runtime, because it's been used like on servers and clouds where you have like all these huge applications that need to respond in a quarter of a millisecond or whatever. And then you have Mono, which was tuned due to the Xamarin and the mobile background to be a very small runtime, a very lightweight runtime that is suitable for static compilation like with LLVM. Because for example on iOS, we cannot do JIT. Like Apple doesn't allow dynamic code generation on their platform. So what we need to do is we need to pre-compile everything in your app to native code ahead of time. And that's something that Mono is very good at. And that's something that Mono will bring into .NET 5. And then there's this new target, which is called WebAssembly, which is, we'll talk about it later on, but it's kind of similar to the constraints that you have on iOS or on mobile in general. And does everyone know what WebAssembly is? Okay. So I'll talk about it on the next couple of slides, but it's basically a way for you to run code inside the browser that is very near to native speed. And it has a lot of restrictions, but it has a lot of nice benefits as well. And some platforms will ship with, or will have the ability to use both the CoreCLR VM and the Mono VM. For example, on Linux and Windows and Mac, obviously we have CoreCLR and Mono working there, no issue. So what you can do, or what we basically intend to do, is to provide some kind of flag or CSproj like entry to switch between the two runtimes, because maybe you want to like take advantage of the capabilities of the Mono VM, or you want to use the CoreCLR. And on some platforms or some targets, you just have one. For example, on iOS, there will be just Mono, because there's no point in porting CoreCLR to iOS if Mono is already there. And the same applies to CoreCLR. So for example, for some cloud or server workload, you probably will want to use the CoreCLR, which is tuned for that. And something that we will be bringing from the Mono and Xamarin ecosystem is there will be interop with Java, Objective-C, and Swift. So that's something we needed to do for Xamarin Android and iOS, because when you're calling into, for example, some Android framework code, you're essentially calling into Java. So the .NET, the Mono on your app needs to know about the other side of the fence, basically. So what we are doing is we have a thing called the Java Bridge, which bridges the two worlds, the .NET and the Java world, and it allows us to basically keep track of which objects are alive on the Java side, which objects are alive on the .NET side, so that the two GCs, because Java also has a GC, so that the two GCs basically don't interfere with each other and just basically collect something that shouldn't be collected because it's alive on the other side. And that's something that will be coming to .NET 5 as well. So for example, if you have some Java library that you want to use, you'll be able to call into it with that capability. And the same applies for Objective-C and Swift. And yeah, there's a different technical implementation behind it, but it's kind of the same concept. Yeah. So what we are working on right now is mainly making sure that Mono can consume the CoreFX libraries, so the framework implementation. That's the second point on here. Because we want to use that for the WebAssembly target. The WebAssembly target will be using the Mono VM and using Mono AOT compilation. And today, like the thing that ships in preview right now is still using the Mono implementation of the framework, but it will be switching over to the CoreFX implementation. And for that, we basically need to ensure that the CoreFX implementation works on top of Mono. And yeah, so we have a lot of stuff, a lot of work to do to make sure that works. And we also need to make sure once we're there, we kind of tune CoreFX to be as efficient and as lightweight as possible, because with the Mono implementation, we had a lot of time to make sure we could make everything as small as possible so that works well on the mobile devices, and with CoreFX that hasn't happened so like as of yet, but we will do that as part of that web. And once that's done, we can start moving Xamarin over to this environment, so that a Xamarin Android app, for example, would be using the Mono runtime and running the CoreFX BCL implementation. And then there's also other stuff like I said, everything in .NET 5 will be using the SDK style projects. Right now in Xamarin we do not use the SDK style projects by default. We will be changing that. So once that's done, yeah, you can use the SDK style projects everywhere.
Any estimations when this will be, or when a beta will be available?
I don't have any idea yet. It's still something that needs to be done. And it basically, this one is a prerequisite for that one, so until we finish that one, we cannot really do this. So yeah, well, we'll see. And then the other thing that will happen, which is also basically kind of prerequisite over there, is that we will run Visual Studio for Mac on top of the CoreCLR runtime. Today it runs on top of Mono because Visual Studio for Mac is using the Xamarin Mac toolchain, so it can integrate with the Apple ecosystem, and that will change. And Visual Studio for Mac will be running on top of CoreCLR, and for that, the Objective-C bridge and interrupt stuff will need to come to the CoreCLR. And that's also something that's like, this is step 2, this is step 1, so once we figure out that one, we will work on the next stuff. Yeah. So how did this thing start? So in December of last year, a bunch of us met in Boston, where Xamarin is headquartered, and a bunch of the .NET Core guys and Unity and Xamarin people got together and basically kicked off this whole effort of unifying the different runtime implementations and framework implementations. And what we did so far is we defined some kind of minimal layer that kind of defines the interface between your runtime and the managed framework. Because as you might guess, the runtime needs to know a little bit about the managed implementation to work. And that's different between Mono and CoreCLR, but for like 99.5% of the code, it will be basically unchanged between CoreCLR and like CoreFX and Mono. And yeah, what we've been doing so far is we're running the CoreFX tests that CoreFX produces on top of the Mono VM. And we had great results so far. It seems to be working fine. There are some gaps that we still need to address, but we were able to run a standard ASP.NET Core app on top, like using the CoreFX implementation, but running on top of the Mono VM just as a proof of concept, and it works fine. Obviously, it still needs some improvements, but at least it seems to work. Yeah, so this is just a screenshot from our CI environment. Right now, we are just running Linux, Windows, and Mac on 3 platforms, so x86, x64, and ARM. And that's just 1.2 million unit tests that are being run, which is... Huh? So yeah, it's fine. It's a lot of that is parsing. I do need to make a note that we did disable a few tests that are testing stuff that we know we still need to implement in Mono. So for example, there's a feature called collectible assemblies, which is kind of the successor to the app domain stuff, which is not available in .NET Core. We still need to implement that. It's work in progress. And also stuff like the new hardware intrinsics, which allow you to basically write like the specialized processor instructions, for example, for like computation, and that's also something we still need to do. But it seems to be, at least from these numbers, it seems to be working quite well. Yeah. So WebAssembly. This is a very interesting target On their website, how they define it is it's a binary instruction format for a stack-based virtual machine, which basically is a way of saying that it's something you can compile to. It's a target, so it's something that a compiler knows how to emit code for, and what it's being used for is it runs in the browser. So it's kind of an alternative to JavaScript, but it's not. Like some people think that WebAssembly somehow compiles or translates into JavaScript. That's not true. WebAssembly feeds directly into the runtime environment of the browser. So JavaScript and WebAssembly basically feed into the same engine. So WebAssembly, the goal is to run very, very fast at near native speed, and yeah. And it's shipping already in a lot of the browsers. So even on my 2-year-old Android phone, I got a browser that can run WebAssembly code. So obviously it still has some new features that are being developed, but it's working quite well already. And at Microsoft, we're using it in the project called ASP.NET Blazor. And there's also a lot of community involvement there. So we have one guy from the Uno platform, which collaborates with us on our chat service, and he's been doing a lot of great stuff with his framework there. And there's also other frameworks like UI and yeah. But for Microsoft, the official stuff that is using WebAssembly is ASP.NET Blazor. And with WebAssembly, we kind of have two modes right now. We have the interpreter mode and the AOT mode. And the interpreter mode has the benefit of being very fast at startup and very good for basically having a short iteration time. Because the ahead of time compilation takes a lot of time, which is not an issue if you're like releasing something and just want to have it as optimized code as possible. But if you're just doing some debugging or changing some stuff, you want to have like a fast refresh and not need to wait like 2 minutes until the app is compiled. So we'll be using both modes. WebAssembly, as of right now, has a couple limitations. You cannot do threading. Like JavaScript, you just have one thread. That is something that they are changing right now, and it's already rolling out to browsers. And I saw a pull request from our runtime engineer adding support for that, I think last week. So that will be really nice, because a lot of the quirks and workarounds we need to do to basically work around the fact that you only have one thread, which is something basically no other system has, will solve a lot of issues. And something that they're also thinking about is having some GC integration with WebAssembly, because a lot of like runtimes, Java, .NET, other implementations do need a GC. And right now we're shipping our own GC. But what if WebAssembly had some kind of interface where you could just plug in and then the GC would ship with the browser? So that's something that is still being looked at by WebAssembly team. And WebAssembly is like a cross industry standard that is being developed. It's not something that like we drive or we participate in the standards process, but it's kind of like across the industry thing. Yeah, so I wanted to show some quick demo about what's possible with Blazor stuff, unless you have some questions right now. Okay, so let's see. So can no. Can everyone see what I'm typing here? At least. So Blazor right now ships as a kind of preview. So what you need to do is you need to install the latest .NET Core 3 preview and then also install the latest Blazor preview. There's some documentation on the Microsoft documentation page, So you just need to install two things, and then in your .NET New templates, you will have the Blazor client-side template. So Blazor kind of has two modes of operation. Blazor server-side is the kind of classic thing where you render, like where you compute something on the server side and just ship the HTML down to the client. And Blazor's client side is the one where WebAssembly comes in. And the difference there is that everything runs in the browser. So all of ASP.NET Core that is producing your HTML will be running in the browser, not on the server. And that obviously has a lot of interesting implications. So, for example, we can do .NET New Blazor. Let me just create a new folder here. Let me just bring this back. I guess it's better for the guys in the back. So I just do .NET New Blazor, and then the .NET CLI will create some files in here. So it's mostly just random like pages. Razor is kind of the syntax that they are using on their server side for templating. And then we have a program C# file and some other files. And let me just do a quick .NET run. It's now compiling the thing in the background, and in a few seconds we should get some server that is spinning up, so we can just take a look at this thing in the web browser. So it's basically just like some kind of hello world template that has a few different pages, like count, that you can click on, and it will increment the thing here. And you might be thinking, okay, this is kind of something that I could already do 10 years ago, but the interesting difference here is that everything you see here is running inside of the browser. So if I do view page source, you will see that there's basically nothing in here. We're only using a little bit of CSS, and then we're just using the Blazor. There's some little bit of glue code that is written in JavaScript that boots up the whole application. And if I take a look at the network request that this thing is doing, if I just hit refresh, you will see that the first thing that gets loaded is this blazor.webassembly. Can you see? You can probably cannot see it. So what is being loaded here is this Blazor stuff, and Blazor then loads mono, and mono also has a little bit of glue code, and then we have mono.wasm. .wasm is basically the format that the WebAssembly binary is delivered as, and this is the mono runtime compiled to WebAssembly, and it's basically just some binary blob that is being initialized by the browser. And then the interesting thing here is you're seeing DLLs here being loaded. And this is actually unmodified .NET IL. So what you're downloading here is exactly what you would have basically gotten out of your C# compiler. And we're running all that inside of the browser. So this is kind of cool. And yeah, I think I need to stop because we're running short on time, but yeah. Does anyone have questions? Yes?
So when sort of the concrete sort of release date of .NET 5?
Sorry, I didn't get the whole
Which
question.
sort of more concrete release date of .NET 5?
The release date?
Release date.
Yeah, so November 2020 is when we are planning on releasing .NET 5. And then each November we will release the next version of .NET. Yeah.
Is it going to be a kind of a migration code application along with .NET Core for the previous application, which is currently running on .NET 4.8 or something?
I don't think there's something like, at the end of the day, your existing C# code should basically be compatible with the whatever is available in .NET Core. So you just need to recompile, unless you're using some features that are not available in .NET Core, for example, app domains. But I don't think there's any like translation or migration thing. At least I'm not aware of anything like that. Yes.
And you still load the DLLs here in this set. This is the IL.
Yes.
Do you plan to compile this to WebAssembly?
Yes, that is actually, this is just like one mode of operation where it just downloads the DLLs without static compilation and using the interpreter to run it, because it's faster this way. You can already, I think, I don't know if it's in the current preview, but it's possible to compile all that stuff into WebAssembly using Mono's AOT engine, and then you wouldn't see like DLLs in here. You would see .wasm files. Or I think it's merged into one. I'm not sure, but you can compile it down to native code basically. Okay, no more questions. Then thank you, and